Right. Sir, notes not there, sir. Anybody waited for the notes? And yesterday night I attached 8 o'clock around. Right. So can I go for conclusion? Remaining all parts where small conclusions are there. I will conclude it all. Right. Okay. Today is Saturday. Let me conclude and start the new week by Monday. Like this. Somewhere we started JVM architecture. We started somewhere. I'll go back once. We are concentrating on programming components. Actually, programming components training is going on. So in that process, you completed only 2 components you completed. One is variables, one is methods. Directly or indirectly, the informations about variables and methods available in your notes already with a few programs. Okay, right. Then Monday onwards, we are planning to start the remaining 2 components, that is blocks and constructors. We are going to start it. That's a plan in a syllabus part. Okay, right. So in that process, we are under object-oriented programming concept. We are under object-oriented programming concept going on, still going on. Still many levels we have to cover under object-oriented programming concept. Means presenting your programs in the form of class object concept. In this week only subclasses concept came, right? Last week only programming started slowly. This week only the subclasses concept came. Still working is going on. Okay, right? Immediately the conclusions will not come. You have to wait it. So we are entering into week 4 indirectly. So object-oriented programming concept is going on, sir. Still we are under, right? Okay. We are concentrating on class object. Still going on, right? Class construction is going on. Wherever the need is there, we are getting some objects. We are working like this. Class object discussion still going on. We are under object-oriented programming concept and we covered 2 alphabets. Like this, the course is going on. So in that process, somewhere I given a title as object-oriented programming concept somewhere. Somewhere I given object-oriented programming concept. So where I will give that title to you means somewhere I'll start data types in Java. I will start it. Somewhere I'll start data types in Java. I'll start it. So data types means types of data we are expecting as input to Java program. We call it as data types in Java. These data types are categorized into 2 types, primitive data type and non-primitive data type. So primitive data type means a single value data format. The meaning is whenever you write int a is equal to 10, the variable a declared by the type int. So it can hold only single value. That's the concept. So all these primitives comes under single valued data formats. Means byte, short, int, long, float, double, char, boolean. Only 8 types will be there. So non-primitive data type means group. Suppose if we take employee details ed is equal to new employee details, there group will be there. Employee ID, employee name, some method. Collectively they are staying together. We call it as group format. So class comes under group format. That's the meaning actually. It accommodates group. So non-primitive data types, we call it as group valued data formats. There are 4 types are there. Class, interface, array, enum. So remaining 3 not entered, only class has been entered. So in that process, whenever after giving some category under primitive, non-primitive, whenever I want to introduce one class to you, I took a title known as object oriented programming concept. I took a title. So there I made a statement to you, the process of constructing programs using class object concept, we call it as object oriented programming concept. Under this object oriented programming concept, we control or we work with non-primitive data types like class, interface, array, enum. So there we have been started. Under that we took one class actually. So class general definition, it is a structured layout. Still information not there. You have to wait it. Because class will come, one biggest structure will come, you have to wait it. Structure means maybe design or model, whatever it may be. You have to wait until that structure comes. Still class is holding only two components, one variable, one method. Block not entered. Monday the block is entering into class. Constructor not enter. Constructor is coming into class by Tuesday. Like this, the components will enter into the class one by one. Then one complete structure of class will come, still not entered. By the definition, we made a statement. Class is a structured layout in Java, generates objects. So in this, I introduced one concept known as object. Right before that, let me conclude. What class can hold means, since last week and this week, last 2 weeks, class is holding variable and method. It is not holding more than that, because I given class in class is a collection of variables and methods up to now. Till last 2 weeks, that only last week and this week indirectly 2 weeks. So classes, how many are there for you? Means two types will be there. Some will come from library, some we have to define it. The classes which are coming from the library, we call it as built-in classes or predefined classes. Example for built-in class and predefined class, we brought a scanner. System also came, string also came. Actually, we are not highlighting the two classes because they'll come separately to you. Just we are using them and we are constructing, but specially we worked with the scanner class as an example of built-in or predefined class. So user defined class means the classes which are defined by the programmer, we call it as user defined classes. Like this, class are two types to you. There is a information available. After that, definitely I want to know, sir, what is this object? Whatever the definition may be there, practically what you done it generally. So heap area is one memory actually. Okay, right. In that heap area, small memories we create, means sub memories. This room is one memory. Example, some 300 square feet, you take it example. Among the table occupies some memory, chair occupies some memory. Understood this point? This also memory only, this also memory only. If we want to say that, they will say entity. So object is an entity, they will say. Entity means one component among that total memory we can identify as a one object, they'll say. Among the total memory, that is one object, they'll say. Means heap area one memory. In the total heap area, small partitions are created. One partition belongs to one class. So if I say like this, student may understand, may not understand. So we prepare a mindset of a student like this. So we prepare and fix it. Object is a storage. Object is a storage or memory related to a class holding the members of class I written on 15th. What members you know? Within 2 days you came across what members means. Sir, the class will have some static members are there in the class. Some non-static members are there in the class. Static members means they'll get the memory within the class only. They will not come. So whatever the non-static members are there, they will come out of the class and get the memory in the object, we say. Means object is giving memory for the non-static members. That's a theory. To educate that only work is going on. So in that process, I made a formal definition there. Now, whenever we want to create that object, we take the support of new keyword, I said in Java, and syntax is class name, object name is equal to new class name. After that, we concentrated on variables, because whenever object came, I must give a variable so that I can have a discussion on variable. This variable will get the memory in the object, this variable in the class, like this I can speak out. So for that, I brought variables in Java based on data type, two types, primitive, non-primitive. Primitive data type variable will hold value. Non-primitive data type variable will hold object reference. That's the information to you. Now, based on static keyword, the variables can be two types, static variable and non-static variable. Variable declared with a static keyword, we call it as static variable. Variable declared without a static keyword, we call it as non-static variable. Static variable will get the memory within the class. Non-static variables, two types again. So the non-static variable declared outside the method, we call it as instance variable. The same non-static variable, if we declare inside the method, we call it as local variable. This instance variable will get the memory within the object. Local variable will get the memory within the method frame. That's a theoretical information. In a general assignment, whenever we give some assignment like yesterday, check the branch, we said. Whenever you say check the branch, now your wish, you can write one subclass, you can write anything. For logics, restrictions will not be there. Whatever the idea student will get it in practice purpose, you can do. So no restriction for it. But we asked to take one subclass concept. So in that situation, what you have to do now? Variables, always you take instance only, don't take static. Sir, in what situation we take static means whenever we want to keep a component shared among multiple objects, means if you want to show that for all the multiple objects, we take static, unless all are non-static in general practice. So like this, I given information about variables. To show that variables, I drawn a diagram to you. So whenever I want to present one diagram to you, definitely I must go with JVM architecture. I must go. Got it right? Now I started there JVM architecture to show the locations. Why means giving grip to the student, location of class, location of object, location of execution. Majorly we must create one imagination, because JVM means one imaginary set of a developer, actually. Imaginary set, that is. So we developers only imagine it. The locations temporarily they are available there. We access. Virtual means does not exist. No. Virtual means what? Does not exist. Virtual machine means one imaginary set. One imaginary set organized by the Java developer to construct applications. We imaginate one structure. In that structure, you must know where is that class available, where is that object available. For that, I concentrated on JVM architecture. Today, I want to conclude that. Why I not conclude up to now? Because all the methods are coming to Java stack area and executing. So how they are coming now? Means I took like this. JVM architecture, anyway, JVM internals we say. JVM stands for Java Virtual Machine, and which is used to execute Java bytecode. Means we are preparing the mindset of a student in core Java. Don't look into operating system. Don't look into machine. We never look actually. Because of this reason, we are platform independent. We are not bothered what type of operating system the system contains. Architectural neutral. Neutral means zero. Architectural neutral. we never think about what kind of architecture we had. i3 processor, i5 processor, i7 processor, we never bothered, because we had our own execution environment, that only JVM. So slowly we are preparing the mindset of a student to convert your imaginations into JVM. Don't look into RAM, ROM, cache memory. You must not look that, because you must not go down. You must look into our imaginary form. That only we are trying to create one imaginary set for a student. For that only we bring that JVM architecture and internals. Why I brought that there? Because when the variable came, I must show the memory for the variable. Because int 4 bytes, float 4 bytes, some memory I written there. So this memory is coming means I must show the location. If I don't show the location of JVM, again the student will think, sir, RAM memory, ROM memory, C drive memory, he'll ask it. So now you never ask me, no? So where is this memory means you will say heap area. Where is this memory means in the class. Where is this memory in the object? You will say, I want that only. You must not say in the RAM came, it is out of RAM. You must not say, because architectural neutrals and platform independence. To generate that imagination only, we bring that JVM bit early, we brought it. There's a reason behind it. So below that, I written, there are 3 partitions available in virtual machine. Only 3 partitions. One is class loader subsystem, runtime data area, and execution engine. 3 parts. When you are reading also before interview, read them once and remember the terms. Right? They will ask, if you are a fresher, they'll ask 1 or 2 questions about your environment. Means about that machines, they'll ask 1 question, 1 or 2 questions. In your technical papers are there, there'll be 2 or 3 questions, they'll put on JVM. What is JIT compiler? What is interpreter? Like this 3 or 4 questions, they'll keep on your environment. To answer that 3-4 questions only, we write the notes actually. But moreover, everybody should remember that names before interview. Daily reading not needed. Daily the 3 diagrams I am drawing, method area, heap area, Java, that only you remember it daily. When you are going for interview, you must open these notes and read once very carefully. There are 3 parts available in JVM. So the JVM diagram I drawn somewhere, I'll open it 2 minutes. Today conclusion, no, I'm concluding it anyway. This is JVM flavor anyway. JVM has 3 partitions, I said. One is class loader subsystem, one is runtime data area, execution engine. What that class loader subsystem is doing now, you written 3 or 4 programs already. Okay, right? Sir, Java followed by, before that compilation process. After compilation process, every class will have their own dot class file. That point you observed that in this week, I think. Every class will have its own dot class file. Suppose 5 subclasses, 1 main class I written, part of your arithmetic operations. There, 6 dot class files came. Among that, we are sending 1 dot class file onto JVM. What is the dot class file now? Main dot class file. Java followed by main class be due to the JVM. By using a command known as Java. So who is taking that dot class file means class loader subsystem will take that dot class file. That only concept. So class loader subsystem will take that dot class file and load it onto runtime data area. That's the concept actually. So whenever it is loading, of course, the class loader subsystem will take the support of loaders. See, here also one supervisor will be standing there, somebody. Below, under him, one loader will be there. So they will instruct it, loader will do. They'll instruct it, loader will do. If I am late, immediately one message, they'll keep it. Venkatesh sir starts the class by 7:20, they'll start it. Because they'll have a touch with me from morning onwards, they'll have a touch with me before my class starts. Means what? They are class loaders. Once I loaded here, they'll close the door and they'll go. So class loaders means one supervisor it is. It loads the class onto runtime data area with the support of loader. That's the concept. So where it loads now means runtime data area having 5 partitions. Everybody should remember the names also, right? For interview purpose, you must by heart that names. Method area, heap area, Java stack area. These 3 very easily you can remember it. Remaining 2 not completed. Java PC register area not completed. Native method area not completed. Today I am giving the notes on them. That's a plan. Got it right? So already you know method area, heap area, Java stack area. The memory block where the classes are loaded. See, I written a plural form on that day. Classes are loaded. Means what? All the classes will be loaded onto method area only. That is a rule. So which class will come onto method area means, sir, main class will come first. So remaining subclasses will come based on their requirement. Means whenever they want it, they will come. Unless they will not come. Example, arithmetic operations. First main class came. After that, a division class came. Remaining subclasses not entered in the diagram. Why only division came? Because user selected division. Means what? Main class is coming first. Remaining subclasses will be loaded based on their requirement. That point to be remembered. Small things what we are speaking, small informations what we are giving, that all you must remember it. They're all interview purpose behaviors. Small things also you must remember it. We'll show the flow diagrams to educate that concept to you anyway. So here I given one information to you. While class loading, static programming components. Here static programming components means maybe static variable, maybe static methods. From Monday onward static block. Like this, static programming components are available in the classes. While class loading, the static programming components will get the memory within the class. Means they'll get the memories. Once main method got the memory, because main also comes under static programming components. Because on that day you cannot catch it, but today after writing 3-4 diagrams you can catch it. Sorry, 3-4 programs you can catch it. So main also comes under static category. So once main method got the memory within the class, then it is automatically copied onto Java stack area to start the execution process. That feature is available for only for main. The main, once memory got it, got the memory means automatically copied onto Java stack. Once it is copied onto Java stack area, there your execution engine will come actually. Your execution engine will come there actually. Then I written the memory block where methods are, I am writing this. The memory block where the methods are executed is known as a Java stack area. I written a plural form again. Methods are executed means first main method will come, then remaining methods will come based on the call. If it is a static method, we call with class name. If it is a non-static method, we call with object name. So who is calling these methods means main method will call these methods. The main is the first method copied automatically onto Java stack area to start the execution process. This main method will call remaining methods for execution. It's a theory. So finally, method area where class loads, Java stack area where execution is happening. Then what is heap area means where objects are created. Where objects are created. Final conclusion is nothing but method area where classes are loaded, heap area where objects are created, Java stack area where methods are executed. Understood, right? Right. After this one, remaining 2 parts are there. Sir, what is this 2 parts? To explain the 2 parts only, today we are entering into that. Continuation, start it. JVM architecture, continuation. Now comes your PC register area. PC register area. Now I am writing the notes on remaining parts. See there? Here PC register area is there. Native method area is there. Here execution engine is there. JNI is there and so on, right? I am writing them. They're all small things only. Major part completed. Method area, heap area, Java stack area is the major part. Remaining we are concluding. Remaining parts we are concluding together. Okay, right? Now PC register. Make a statement. Program counter. PC means program counter. Program counter registers will record the status of method execution program counter registers will record the status of method executions in Java stack area. Program counter registers will record the status of method executions in Java stack area. Every method which is executing in Java stack area will have its own program counter register. Every method which is executing in Java stack area will have its own program counter register. All these means if two methods are running, two program counters will be there. All these program counter registers are opened in a separate memory block. All these program counter registers are opened in a separate memory block known as PC register area. All these program counter registers are opened in a separate memory block known as PC register area. Separate memory block known as PC register area. Look here. Here register means general meaning. Register means record actually. Have you registered your names? English meaning is have you recorded your names? That's the meaning actually. Here program counter recording. Sir, what it is going to do, sir? See. 100-day one diagram is there for us like this. This one to explain that variables and methods. Anyway, see there. Suppose here first method is coming. This one. First main method is coming here now. This is the main method coming now. First main method only will come. When the main method comes now, so imagine it here. This is one PC register area. Imagine it. This is native method area. Imagine it. 2 blocks. One is PC register area, native method area. Now when the main method copied here, first method main will come. Yes or no? Right. When the main method comes, related to main method, one PCR will be created here. Program counter register related to main method. One program counter will be created. This program counter will be monitoring this method. It will be monitoring. That program counter will be monitoring. Means what, sir? See, now demo methods 1 dot m1 means we called this method. Main class method will call the subclass method, no? Right, call the method. Now when the main class method means main method called this m1, now m1 method came for execution here. M1 method came for execution here. When the m1 method came for execution now, stack, no? Stack means what now? First in, last out, or last in, first out. So it leaves the main method, go for m1 method. Execution control will go to m1 method. So what this program counter will do now? In the line number 1, there is one method call. Because of that method call, the main method has been stopped. The main method has been stopped. Means it is stopping the main method, no? It is stopping and the control is going to m1 method. Means it stopped the main method, it records. By which line it has been stopped, it records and keep it. Now the execution control will go to m1. When the execution control goes to m1 now, it creates one more frame here. Sorry, one more PCR will be created here. This program counter register belongs to m1 method. Like this, every method will be opening with its own program counter for monitor. Sathiri. Now here one program counter came. Now the execution is happening now. When the execution is happening, line number 1 executed, line number 2 execute, records actually. Now here no disturbance. No disturbance what? Execution control is not leaving this m1 method and going anywhere. It is completing the m1 method. Once it is completed the m1 method has been destroyed. Automatically PCR also destroyed. Because without any transferring here and there, it has been controlled. Sorry, it has been executed. Once execution completed, PCR destroyed here. Now, once destroyed here, now this m1 method execution completed. After m1 method execution completed, execution control will come to main method. Yes or no? When it comes to the main method, now the execution control don't know where it has been stopped. Now, PCR will give the information. Understood this point now? That PCR will give the information. You completed line number 1 because of method call. You left this method and went away. You start from the next line. That is the information. So PCR will record the status. So where you have been stopped and where you ought to start it. That information is available in the PCR. This design is not a new design. It is an old design already available in the operating system.
In operating system, if any CSC students are there, for you, PCB, process control block, is there in operating system to control the processes. VLC player, one PCB, notepad, one PCB, WordPad, one PCB. Every process in the background, one controller is there. That is PCB, process control block. The same thing they brought the design as a PCR here. PCR means here program counter register, but the design that only. We are monitoring the execution process. It's a theory. Now what happened now? This PCR related to main will give the information. You completed line number 1 and you went. Then it says, okay, I'll go with the next line. Then it records. You came to the next line. In the next line now, there is no leaving this method is there. It is executing that object creation busy now. Object creation completed. After object creation completed now, it comes to the next line.
In here, next line, this one. When it comes to the next line now, again you are calling M2 now, right? Now M2 must be loaded now. M2 came here. When the M2 came here now, M2 related PCR will come. M2 related PCR will come. M2 related PCR will be open. It is monitoring this M2. Whenever it came here now, so whenever it came here now, it records. Your status is recorded. You left here. Some informations are recorded here. By this line, again you left this main method and went away. Right? Okay. Now the execution control is busy with this method. So here recording is going on. Which line you are executing? Which line you are executing? Once execution completed, this frame destroyed. This also destroyed. Whenever it destroyed, again it come back to the main execution control. Again it come back, it gives the information. You stopped by particular line number. Understood this point? All right. Once this method frame destroyed, this also destroys. Means what is PCR now? Sir, program counter register. Program counter means line by line, I am recording for you. Why means if you leave this method and go, when you come back, you must know where you stopped. For that, I will record it and keep it. That's why I written a points here now. Program counter registers will record the status of method. Status means which line it is executing and so on. Every method which is executing in Java stack area will have its own program counter. How many methods came onto Java stack area? That many PCRs are created. All these program counter registers open in a separate memory block known as PC register area. That is a concept. All of you understood this now? There is one small theoretical concept in the background about PCR. Make it. Now come your native method area. That is for reading point only. If anybody asks what is PCR, you say it. Native method area. Native method area. The methods which are declared with native keyword are known as native methods. The methods which are declared with native keyword. The methods which are declared with native keyword in Java library. Are known as native methods. The methods which are declared with native keyword in Java library are known as native methods. Native methods. In your Java library, some methods are declared with native keyword. Such methods by terminology, we call it as native methods. So let me open that some native methods roughly to educate you. some class I am opening now. Object class. One class is there I am opening. Here some keyword will be there. NATIVE native, NATIVE native, NA. These are all native methods. So, sir, what is this specialty of this method? Why they given native? Native methods internally having C or C++ codes. That methods internally having C or C++ codes. Your other written that method with C and C++ code is there. He kept that method in the Java library and he want to indicate the developer this method belongs to C and C++ code because he added one native keyword and giving information to me. The method is having C and C++ code. Make a statement. Native methods internally having C or C++ code. Native methods internally having C or C++ code. C or C++ code. Your other kept a few methods part of your Java library which are having C and C++ code. It's a theory, right? Look here. Now, native method area. Sir, it is method area only. This is method area, not now. Method area, native method area, two parts actually. Method area, Java area, native method area, C and C++ area actually. So many C or C++ codes are coming, they given a separate place. You sit there. So when these native methods are used in Java programs, class loader, your class loader is there, no? That class loader will identify which method it is because class loader subsystem internally having decoders also. They can decode. They can decode it. They will raise linker problem. They raise some algorithms are there in the class loader, but we highlight only loader, but they can decode it also. They can decode it. So in the process of decoding, they'll say which one is native method, they'll say, and these loaders will load that native methods into separate memory block known as native method area. The overall statement is like this because make it when we use native methods in programs, when we use native methods in programs, then they are separated by then they are separated and loaded onto separate memory block known as native method area. When we use native methods in programs, then they are separated and loaded onto separate memory block known as native method area because they are having C and C++ codes. C and C++ codes. Look here. Here doubt will come. Sir, I am a developer in Java. I don't know C language. I don't know C++. Java developers never know C and C++. Only freshers will know. You people newly came out of your engineering colleges or any colleges, you will know C language, you will know C++, you will know Java, you will know Python. You know more languages than developers. You go to real-time market and they know only one language. Remaining all they don't know. You take myself, I don't know C language. I forget it. So since many years I am speaking about Java, I am working with Java. Automatically, if you don't touch one language, the touch will go. So no developer will know all the languages, and only freshers are the confused students in the market, means you people. Why confusion? Means you know more language, that is a confusion. When you know more only, that is a problem. Sir, if I know more only, the problem is coming that only. Why? Most confused person in the market means fresher, aspirant, who is opting, who is planning to opt a job, and he is more confused. So for you, C and C++ you don't know actually. According to developer, I am speaking. So your other said, if you are a Java developer, you don't know C and C++, we know already. So we are only writing a methods related to C and C++. We are copying that methods into your library. You use them. If you open it also, you cannot see the code. I am not forcing you to write C and C++. We never write native methods, because I made a statement here. In Java library, they are coming from library, we never write. So use them. Okay, sir, I will use it. Whenever you use it means what? You call that method, or you run that method, something you will do. You are going to use that method. Whenever if you use that method, loader will identify. Because you are loading, no? Loader will see that you are a C and C++ method. You are mixed with Java and going. Wait. Don't sit with Java people. Come out. That's called decoding. Decoders are there already. Every loader will have internally decoder. Now that supervisor is a decoder also. They'll check your ID card also immediately. They'll decode it immediately. They'll say, stop, show your ID card, they'll say. Means they are decoders also. Not only loaders, they are decoders also. So loader, indirectly in the background, decoding will be there. So they decode it. They'll say, you are going with Java people, you wait, come out. Because your C and C++ code, don't mix them. So they will separate and they'll ask to load separately. That only native method area. Now Java, all related components will come and sit in method area. And C and C++ codes will come and sit in the native method area. Both are nearer only. Actually, in the diagram we are drawing in the last, but they are attached. Okay, right. Now, from this native method area, one method will come to Java stack area for execution. On demand, they'll come. No, method should come for execution or not now. Now that C and C++ method, nothing but native method, based on the requirement, it will come and load onto Java stack area. Now execution engine will come. Execution engine will not understand C and C++. Because execution engine executor is a Java people, no? They will not understand. When they don't understand, immediately the execution engine will take the support of JNI. I drawn one diagram. Can you see JNI there? JNI. I commented, no? What is JNI now? Java Native Method Interface. Means this JNI is supporting execution engine to execute native methods, because I drawn the arrow to native methods. Right? Okay. Make a statement. Next point. Execution engine will execute native methods using JNI. JNI means Java Native Method. Java Native Method Interface. Execution engine will execute native methods using JNI. Java Native Method Interface. Java Native Method Interface. Look here. C and C++ code means separate libraries again. C and C++ has separate library, no? Right. Your other said the methods related some C and C++ library, I'll keep in your library. Right? That library is available in one part known as native method library. One part will keep it, where that C and C++ related few libraries we kept it. Means what are needed for the methods, they kept it. So that JNI while execution uses native method libraries is going to use it. And this JNI will be supporting execution engine. That's the concept. It is supporting. When it supports now, when the method come from here, that JNI will enter for the execution. That's the concept. When the method not there, JNI is not involved. That only concept. That only internally, the execution engine will take the support of JNI for executing native methods. Make a statement. While execution here, while execution, JNI uses native method libraries. Native method libraries. Uses native method libraries. Now, here they will ask one question to you in interview. One question is there for you. So here I can comment it as C or C plus coded methods. Simply you can say native methods. C and C++ coded method, nothing but native methods. Right. Then they will ask this question, why? Why we are having native methods in Java library? Why they are needed? Why your author brought this concept? Why? Java means you can do only Java, no? Why you are bringing again native methods inside? They'll ask a question to you. Why Java library having native methods? C and C++ methods, why they are sitting in Java library? One FAQ is there. Make it FAQ. Why Java library? Why Java library? Java library having native methods. Why Java library having native methods? Why Java library having native methods? Right. All of you look here. Sir, this is our JVM from day one onwards. Like this we draw. Anyway. Below this always I'll draw one operating system. I'll draw. One operating system. Below this operating system, we had a machine. Our machine is there. This is machine. Machine means your hardware component. Anyway, this is your hardware. This is our JVM, Java Virtual Machine. Here, our application will be running. Our Java application will be running. So the Java application which is running in JVM environment, our environment. Of course, JVM will not run. Will not run means what? JVM will sit on OS only. Will sit on OS. While installing also platform dependent. It is not independent. While installing, yes or no? While installing and downloading your software is dependent. Windows based JDK, Linux based JDK, Mac OS based JDK, you download it. Means what? It is platform dependent while downloading and installing. After installation, it is independent while execution. That is a different area. Now, your Java application want to communicate with IO. IO means what now? Input, output. So, your Java application want to communicate with input output. Now that input output connections belongs to your computer machine, virtual machine. They are all connected and these are all connected to your virtual machines only. So every component is under the control of one driver, right? Audio driver, video driver, motherboard driver, keyboard driver, mouse driver, flash driver, network driver, all are drivers only. The drivers are C or C++ codes. Because C language will be there until the software dies. The day on which the software dies, and the C language will go, I think. It is a base and root. Because platform dependent things are done by the C and C++. Because your Balaguru Swami will write, my language is middle level language is A. Because I can speak to machines, I can control the machines, I can interact the machines. That only embedded C is there, micro C is there, pro C is there. They're all C flavors they are all. What you are learning is a normal C. That is different issue. So C language can speak to the machines, control the machines. It can have control over the environment. Because Balaguru Swami said that in my research, I observed C is a middle level. It looks like high level, but it can speak to low level. So I can term it as a middle level, the other set, because it can interact with the machines. Now, the total down environment is C and C++ environment. OS is C and C++ environment. Machines, C and C++ environment. Our environment only Java environment. Understood this point? All right. If I want to interact with the IO device, I took the support of system.in. Now that system.in internally activates some algorithm related to your JVM to speak to operating system, thereafter speak to your machines to have an interaction with the OS buffers. So definitely some requests are going internally. The requests are not Java requests, they are C and C++ requests. Because your environments cannot understand Java and bytecode, they cannot understand. Again, we have to convert ourselves into their environment. For that only, internal C and C++ components are going to support you. That's a theory. Moreover, if you want to interact with the network, network also in machine only. I want to interact with the file system. File system also part of your machine only. Sir, I want to interact with the databases. Database also part of the system only because you installed your database there. If a Java program want to interact with these components, Java program want to interact here, Java program want to interact here, Java program want to interact here. So that all components are out of JVM only. Even your web browser also, whatever the web browser interaction you are doing daily, this web browser also organized part of your Chrome, right? Chrome browser is there or some other is there. They are all part of your OS designs, no? Anyway, they are installed and running based on OS. So this also outside the JVM. So all are outside the JVM only, no? The statement given by you in the interview is why we have native methods. Then you must say, when my Java application want to interact with, the resources, maybe web browser, maybe file, maybe database, maybe network, definitely I must take the support of their environment. That is C and C++ environment, I must take it. For that purpose, your author said, I only will prepare that methods and give to you. You use them. That only concept. To interact with your IO device, system.in, we not written. They only prepared and given that model to us. We are using system.out. Printing out said no. System.out output is going or not now? System.in input is coming or not now? So internally some requests are generated. The requests are related to C and C++. Because of this reason, there is an interaction with that components. Make a statement like this. When not when, Andy. The Java application will communicate with the resources. The Java application will communicate with the resources outside the JVM. The Java application will communicate with the resources outside the JVM using native methods. Using native methods. Using native methods. Look here. We cannot say that C and C++ not available. We cannot say C and C++ is available, but wide range of opportunities very less. Wide range of opportunities very less. So we people now today's scenario, you people, we look for the packages. Sir, I want highest packages. Unless we cannot survive because economy standards has been increased. So definitely who are opting a job and they look for high packages. Then only I can survive, sir, unless I cannot survive. So when they look for high packages and they look for the huge domain, they look at, sir, I want to enter into one domain which has a huge impact in this world. So a huge durability means they look for internet world. So where I can work more means internet world. Internet world is growing and coming. We don't know how much it grows also today. Unlimited, no. It has been occupied. See, in a few years back, and we don't have a mobile concept not there. Right? I don't know how they met, how the friends gathered 20 years back, we don't know. But today, if you keep one WhatsApp match, all will be gathered, no, by evening immediately. Today, that much of communication system is there. So everybody is having one communication system in the internet world. Means huge growth happens in the internet world. When compared to 20 years back or 25 years back, when you compare today, huge growth happened in internet because you are trying to enter into internet world. Because you are selecting the domains as a carrier. So maybe Python, maybe Java, maybe .NET, maybe PHP. I want to enter into internet. Ultimate area is internet world area. So when you try to enter there, any huge range of opportunity may be available for you. That's only concept. Sir, I am very interested in C and C++. You can do it. But range of opportunity is very less because it is a platform dependent. Machine level codings will be going on. Understood this point now? So we cannot say that they are not available. Everybody will have their own work. Right? Everybody will have an opportunity. Every domain will have an opportunity. Need not say that, sir, that opportunity not there here, that concept not there. Every domain will have their own opportunities in the market. But the reason is, we people want the highest range of packages in an immediate way. Because they run for the huge impact domain. So there they look into the domain. That only we are entering into object-oriented programming, we are entering. So who is demanding object-oriented programmers means internet world people are demanding object-oriented programmers because you are entering there. That's a meaning. But still your libraries are holding C and C++ coded methods because they are going to support you to interact with the resources. Network driver, C and C++ only. Mouse driver, C and C++ only. Whenever I want to speak to TCP/IP protocol, when my application want to interact with TCP or IP protocol, network protocol. So network protocol is C and C++ protocol only. That is available in the OS. Everybody knows. It's a inbuilt to OS today. When you install OS, network protocol will come. But my application is running in the JVM now. From JVM, I want to speak to network protocol means definitely I must speak to OS. My request must go to the OS. OS will not understand bytecode. The reason we are not asking OS to depend in my environment, no, it doesn't know bytecode. So if I pass my Java request to the OS cannot understand. So what I must do now? I must convert myself into his environment. Understand that? So whenever I want to convert myself into his environment is C and C++. Then your other said, Java developers are independent people. You cannot convert it. So because you don't know codes, because we only will give a methods to you, that only native methods. We only provide a components to you. We only provide a models to you. We only provide a dot class files to you. We only provide a jars, vars, EARs. They are all we provide to you. Use them to interact with the resources. The level 1 is native method. After that, we give a jars to you, vars to you, EARs. Like this, they'll give to you. Using them, we are going to interact with the resources. Whenever we want to interact with the database, OJDBC 6.jar, they given. Like this, everywhere one component will be there to interact with the environment. Here also, to interact with the environment, we had a native methods. That only concept. The Java application will communicate with the resources outside of the JVM using native methods. Because of this reason, Java library is holding native methods. Is holding native methods. So holding native methods. If anybody asks, you can speak it out. So the finally executor is coming. Execution engine, the last part. Right. Look here. So execution engine means, sir, he is the processor indirectly. He is the major part. I'll speak about your virtual machine normally. In virtual machine, we had a processor. Yes or no? Processor. English meaning is executor. Processor means executor. Process means execute. The component which perform execution is known as processor. It's a concept. Processor is the center of processing unit. So the processor can be called as a CPU according to design parts. This processor will be looking into one area because he is the king of the cabinet. The total cabinet is under the control of one person, that is processor. He only king. Now that king will have one fan also in the head, because only one person who is having fan means a king. The king will be, that king only major part. The king will be looking into one area. That area is main memory. That only RAM. RAM. Random accessible memory. Understood this point now, right? Wherever the king comes, there only they accommodates everything. The king will come to the RAM. They load into RAM. That's the rule actually. That's the rule of your machine. The king will be looking into one location, that is RAM. Random accessible memory. The processor will say, I will come and sit there. If you want me to execute something, you load to RAM. I will not come there. My VLC player is in C drive. King, you come to C drive, and it says, I am a king. I will not come. I am sitting in RAM. Ask that VLC player to come here. I will execute. That only loading into RAM. That's a concept. that king area increases, speed increases. Understood this point now? The king area increases, speed increases. Because of this reason, your components speed depends upon RAM. Because you are buying your mobile phones by seeing the RAM. Because RAM increases, execution area increases, speed increases. That's my concept. Here also, execution engine is the king. I will come and sit in Java stack area. All should come there. Understood this point now, right? Now that execution engine is saying that I am a king of this JVM. I will come and sit in one location. That location is Java stack area. I will not come to method area. I will not come to heap area. I will not come to other areas. No. I will not come there. I will come and sit in Java stack area. Then you said, no, sir, yesterday control is going to method area. Control. Then how the control? Control means king is saying that I had own workers under me. That only control units, controllers. They'll be running under the king. They'll go and look there. Available, can I get it? They'll be reporting to the king. King will not move. He'll be sitting in the RAM according to virtual machine. Here, king sitting in Java stack area. Got the point, right? When the king is coming there, before that, loader is loading the main. The main is coming there or not now? When the main comes there, execution engine will come and check that main and starts. Remaining all, they should come because M1 is coming, M2 is coming, M3 is coming, all should come here only. You come, execution completed, destroy and go. Another person will come. That only. Understood this flavor now, right? So what you observed here now, execution engine is the executor of JVM and which starts the execution process with main method available in Java stack area. It will not go to any other location. It goes to Java stack area. This is not a new design, old design by your machine. The machine also same. The processor will come and sit in the RAM. Finish. Right? We will ask, the OS will request, please maintain some memory with you. Means, okay, I will maintain some memory. That memory is cache memory. The processor says no. Okay. Attach some more memory near to me. Don't attach far away. Nearer to me, attach it. Other than RAM, attach some memory nearer to me. That only cache memory. Understood this point now? So that only cache level 1 class, level 2 class. You can see the textbook very clearly. Computer organization by Maurice Meno. Other is there. Unit also, micro-programmed control unit. One chapter is there. Who are interested, you can read that chapter line by line. Very beautifully written the behavior of a processor. They written very clearly. They written what it does. He highlights the Maurice Meno will highlight. He is the king of this cabinet. If he is not there, processing is not there. What is its behavior? He written one textbook. There's a topmost textbook in the world. If you want to do research in your any architectural model, they have to refer Maurice Meno. That much a popular textbook available to you. There very clearly. From there only our engineers came out. No, our other also came from engineering only. No. So our other took that flavor. If I want to design one machine, if I want to design one virtual machine, I must not leave the flavor. You're not leaving the flavor. So I'll make one area as a RAM. That area is Java stack area. I'll make that king available there. Execution engine available there. To record that processings, I'll create PCRs. Not only your other done. To identify the memories separately, class usage separately, object usage separately, so that I can observe them very clearly. He given method area, heap area. That only virtual machine design. So finally, make a statement. Notes on execution engine. Make it execution engine. Execution engine. Execution engine is the executor or processor of JVM, executor or processor of JVM, and which starts the execution process, with main method available in Java stack area. Execution engine is the executor or processor of JVM, and which starts the execution process with main method available in Java stack area. Now this execution engine internally having two partitions, make a statement, means two translators. This execution engine internally having the following two translators. This execution engine internally having the following two translators. One is interpreter, one is JIT compiler. One is interpreter and one is JIT compiler. Two parts are there. Because of this reason, you will say Java will hold both interpreter and compiler, you will say. It is having interpreter and JIT compiler. Here JIT means just in time. Just in time. Put one arrow and write it. Just in time compiler. JIT compiler, they'll say. JIT, JIT, they'll read it. JIT compiler, or you can say JIT compiler. Just in time compiler. Now, sir, if two translators are there, who is going to start the process? Means interpreter will start the process. JIT compiler will not come now only. Whenever the requirement comes, then the JIT compiler will come like this. When this execution engine is looking into Java stack area, this one will come. Means interpreter will come. JIT compiler will not come. First interpreter will come. So interpreter will start the execution process and executes normal instructions. Make a statement. Interpreter will start the execution process. Interpreter will start the execution process and execute normal instructions. Interpreter will start the execution process and execute normal instructions. Underline the term normal instructions. Sir, other than normal instructions, what is there? Means multimedia instructions will be there. Multimedia instructions means audio, video, image, animation, loading images, downloading images, loading audio, downloading audio. Such actions we call it as, such actions are not normal instructions. Normal means a simple calculation, decoding, loading, reading input, loading into one, that all normal instructions. So normal instructions are done by interpreter. right? When interpreter finds multimedia instruction or bulk instruction means, bulk means what? Loading image of 40 KB, loading image of 70 KB, downloading audio file of some 200 KB, like this. They are called bulk transfer. Such components will be done by JIT compiler will do the work. Make a statement. When it's an internal automated process. When interpreter finds multimedia instructions, when interpreter finds multimedia instructions, or you can say bulk instructions, when interpreter finds multimedia instructions or bulk instructions, then control is transferred to the JIT compiler. When interpreter finds multimedia instructions or bulk instructions, then control is transferred to the JIT compiler. When the bulk data transfer is there, interpreter will give the control to the compiler. Why means compiler will do all at a time. If I given 20 KB, it transfers 20 KB at a time. At a time means once started, not leaving in the middle. That's called compiler. Interpreter will not do that work because interpreter problem is it does line by line. After transferring 5 KB, if anybody disturbs, interpreter will leave that and come out and do the remaining work, and again it comes back. Interpreter means can be disturbed in the middle of process. So your other said, interpreter, if I use interpreter for bulk transfer, it consumes more execution time because I am taking the support of JIT compiler. JIT compiler means transfer all at a time, bulk at a time. Meaning is once started, it will not leave in the middle. So performance will be very high. Right. Here, now comes your second point. You got the information there. What you observed here now, sir, JIT compiler. JIT compiler will execute. JIT compiler will execute multimedia instructions. Multimedia instructions, or you can say bulk instructions, you can say. JIT compiler will execute multimedia. If you upload any image, the image transfer is done by JIT compiler internally. If normal text is moving, then interpreter will do the work. Interpreter will do the normal work, and any bulks are there, JIT compiler will do. Then they will ask a question, why this all headache? You can do total thing you can do with compiler, no. Total thing you can do with compiler. Why you are bringing interpreter again? Why you are going for compiler? They'll ask a question. Why interpreter in execution engine in Java? Because everything you can do with compiler. In C language, compilation compiler, execution compiler. In C++, compilation compiler, execution also compiler. Here, compilation compiler, execution, two parts. Interpreter, normal instructions. Bulks, your JIT compiler. Then they'll ask, why interpreter here? You can do with a compiler directly, no? Then your other side. Compiler means all at a time. It will not accept the request in the middle. If anybody passes the request also, it will not accept. Suppose I given some 20 KB file to Java compiler, example. Until it transfers the 20 KB, it will not leave the action in the middle. So compiler will transfer the total file at a time. If anybody tries to disturb, it will not be disturbed. The meaning is nothing but compiler will not accept any request in the middle of execution process. Make a statement like this. FAQ. Why interpreter in execution process? Why interpreter in execution process? Java people only bringing this interpreter. When we have interpreter, then we can accept the request in the middle of execution process. In the execution process, interpreter is there that can be disturbed and we can accept a new request on demand. When we have interpreter, then we can accept the request in the middle of execution process. And which is preferable for network applications or client server applications. Simply you can say web applications, right? So it is preferable for server applications. All your web applications comes under server applications. If interpreter is there, suppose one user passed one request. It is doing that request. Second user passed the request. It can accept the second request also. That is interpreter.